So I guess what we can do today is first of all, has everybody watched the video I did for last quarter? It's like a 2-hour-long video, but I really went through everything, almost everything you're going to need. Well, thank you, Charlotte. So I don't want to go through everything again because that's not going to be helpful to you. You should watch that video. I want to maybe answer a few other questions on things that I didn't cover before, and then maybe I was thinking just as long as I got you guys on the phone, maybe I'll try to cover some other topics. Like I had a presentation that I did a long time ago on machine learning, and I thought maybe I would do a quick talk on machine learning, you know, a quick overview if you guys are interested in that. Okay, well then, how about if we get started off? We ask. Okay, here's my visual aid. Okay, so what you guys got to do is tell me how many bottles of this using your predictive model I'm going to buy.
Is that coffee?
Is this coffee? I don't know. The real question is it grape juice or wine? If I start acting funny by the end of the night, you'll know it's not grape juice. It has legs. How do you know that? Let's see. Oh, yep, it has legs. Whoa, Richard is a connoisseur. I thought I would do that as a joke. It's grape juice even in the records. How many chlorides? I have no idea. Okay, sulfates are bad. Guys, I'm sorry. I don't know any of the numbers. It has a cool label and it had a good review. So my wife bought it because it had a pretty label. Boom. Okay, so I'll tell you what. Let's get started here. Does anybody have any questions? And we'll. I'm a bit fuzzy on the flag and shifting of the zeros. Okay, fair enough. Because I wanted to get into the zero inflated Poisson. How about that? So do you want to get a little bit of that? Okay, then there we go. So let's first of all talk about what the zero inflated Poisson even is. So let me just pull this thing up, and then I'm going to share my screen in just a moment. Okay, so now I'm going to share my screen. Okay, so here's the notes from the zero inflated Poisson. And really, a zero inflated Poisson model is just simply this. If you look, here's a Poisson model, okay? And Poisson is nothing more than just a linear regression except for its counting numbers, 0, 1, 2, 3, 4, 5. Now, one of the things I want you to take away from this assignment is even though in theory you shouldn't use linear regression for Poisson data, what you're going to find out is it actually does a pretty good job. So you should always try it. It doesn't hurt you to try it, and you might end up with a pretty good model. And the nice thing about linear regression is it's a heck of a lot more explainable than anything else. So always try it. You're going to find that it can do a very good job. However, what you're going to find is that a lot of times you get a zero inflated model. Okay? Now, a zero inflated model, you get that in things like insurance. Most people don't crash their car. So you have a big spike and there's no, people don't crash their car. However, if they do crash their car, this is what it's going to cost. It doesn't cost you $100 and it doesn't cost you $1 million. It costs you like $5,000. So it's like a big spike there, but you get a big jump at zero there. That's called zero inflated. Now, you can model this a lot of different ways. And I talk about it in this guy right here, zero inflated Poisson regression. Okay? Now, what we can do is a couple of different things. One thing you can do with a zero inflated Poisson is just ignore the fact that it's zero inflated. I mean, just model it with flat, plain old, vanilla regression, plain ordinary Poisson model, a plain ordinary negative binomial. Throw that stuff at it because it's easy, okay? It doesn't hurt anything to try. Sometimes it doesn't make a bit of difference or the models aren't all that different, okay? So that's one thing you can do. Another thing is that SAS and a lot of other tools like R and I'm trying to think of probably Python and other languages, a lot of them have customized routines that will account for zero inflated values. So SAS, for example, let me see if I can find one here. Okay, so let me get to SAS just a second. You guys can see my screen. Michael, combo piano.
Yes.
I can't see the chat window. So if someone asks a question, would you interrupt me and because I can only see my screen at this point. So I'm gonna make you the teacher helper, okay?
Sounds good.
Okay, fair enough. So anyways, so if you have this zero inflated Poisson, you can do something like this. Let me get to it here. Here we go. So SAS has proc-gen-mod, which we've been using for Poisson, but if you got a zero inflated model, then SAS has some very special syntax for you. So you build two models. You build one model of, is the guy going to buy some wine, yes or no? And if he does, how much wine is he going to buy? So you're building two models. So that's one way of doing this, and that's one-stop shopping, okay? You're just building everything with one call to one procedure. I don't personally like that. However, you should do it in the homework just because it's good practice. But there's another way you can do this as well. And what you do is you can build a logistic model. Let me see if I've got a good example of this somewhere here. I know I do. I just got to find it here. Let me see. Is it towards the end? I know I've got it around here. Just a sec. I should have. Oh, here we go. It's called the hurdle model approach. Okay, here we go. So what you can do is this. Let me get to the start of this. Okay. Now, the first thing you can do is build yourself a logistic model. Okay? And you can do this with logistic regression. And the nice thing about this, and this is what I like about this approach over everything else, is if you build yourself a logistic model, like in other words, we have I just showed you how SAS with the proc-gen mod allows you to model a zero inflated Poisson model. Gee whiz, I'm flipping all over the place here, and I'm sorry about that, people. Let me go back over here to the zip model. I'm probably losing everybody at this point, and I really most sincerely apologize. Okay, here you go. This is zero inflated negative binomial. It doesn't matter. Okay, now again, I can model it all with one proc call. In other words, I say, okay, this guy here is what's the probability that the guy's going to buy wine, is going to buy zero wine. Okay, that's what that is. Or this is the probability that the guy isn't going to crash his car, or the probability that it's not going to rain. So this is the probability of a yes or a no. In other words, you got that big spike at zero. This is just going to be the probability of what's the probability of having that spike. The next model here is if it does happen, how many are going to happen? So that's what this guy's doing. Now, you can take and break this guy into two models. And this is what I recommend because it's easier and there's a lot of flexibility. So what we could do is I can break this thing. I could take my target variable, like for example, in the example that we had is people, if you take a shower, remember the data that we had of taking a shower and how many minutes of a shower you're going to take. Well, some people might not take a shower in the morning because let's say they're running late for work or something. Or you're one of my kids and they don't like taking baths, okay? So they so what happens is you have a big spike at 0, but then if you do take a shower, it's going to probably be that, you're not going to get in the shower for 1 second and then get out. You're going to go in there, and once you get in the shower, you're going to be in there for 5 or 10 minutes at least, okay? So what I'm going to say is what we could do is I could take this data, and I have the shower length is greater than 0. So I'm going to create a flag here, a 1 or a 0. In other words, what I want to do is model, did the person take a shower or not? So this is just like we did last unit where we were trying to figure out, did the person crash their car, yes or no? Did they default on a loan, yes or no? This is just simply, did they take a shower, yes or no? Now, what I like about this is I can build a logistic model because that's what we did last unit. But another thing that I like about this is you have a lot of flexibility. You could use a decision tree or a neural network or anything else. This is very powerful, a very powerful way of doing yes or no. You can build a lot of different models, whereas if you just use GenMod, you don't have any options. Here, I have a lot of options to build the very best model for predicting whether or not I'm going to take a shower. Okay.
Hey, Don?
Yes, sir.
We do have one question.
Okay, I'll take it.
From Ron J. Isn't it similar to probability severity model, or is it something different?
It is exactly the same as a probability severity model.
Perfect. Thank you.
Okay. So the real question that people ask is, why did we subtract 1? So that's the second question. So now I've got this probability of it happening. Now I want to build a second model, which we just did before was a severity model. Now we're going to say the guy's taking a shower. Now how long is he going to be in the shower? Okay. So what happens is we have this, why did I subtract 1 from the model? Well, the reason why I'm subtracting 1 from the model is because I'm modeling two things. The first thing I'm modeling is it 0 or is it more than 0? Okay, now that I know it's more than 0, I'm going to build a Poisson model. Okay? So I'm saying that the distribution is Poisson. Unfortunately, Poisson can have a 0 value. Okay? But my data is going to have no zeros. It's going to have 1 on up to infinity, and Poisson data really goes from 0 to infinity. So what I do is I subtract 1 so that it's truly a Poisson distribution. Okay? And so then I model it, and when I'm done, I just add 1 to it. Okay, because I subtracted 1 so that I have a purely Poisson distribution like I'm supposed to have. But then what happens is when I'm done, I got to add that guy back. Now, the people ask, what if I don't do that? What if I forget to subtract 1? Is that going to hurt me? Truth is, probably not. But, somebody was asking me, what if I didn't do that? And I'm like, you know what? It probably isn't going to haunt you. In fact, you probably won't even notice. But if you want to be a purist about this, and God knows I'm not a purist when it comes to statistics. I'm an analytic street brawler. So, all I'm telling you is if you want to be a purist, you would subtract 1 from it, and when you're done, you add the 1 back. Okay? But if you don't, it's probably going to be no hurt, no foul. So that's the short answer to this question. Does anybody, have I addressed the question of whoever asked this? Any typing there, Michael?
Somebody is typing.
Okay.
Isn't not presented yet.
Okay, I'm going to...
And it says, okay, that makes sense.
Richard Meyer, does that really make sense? Or sometimes people say it makes sense and it doesn't really, and I don't want to end this call without you getting it. Okay, you get it. Okay, I'm making sure. I'm going to also go through a quick example of it as well. I'm just seeing some of the attendees are typing here. In your previous model, you used target amount minus 1. Yes, I did. Because remember, I broke, I broke that into 2 models. Wait, Chris, I don't think you're getting it. Or who's CHRI? Chris, that becomes a flag for the logit of the zip. No. Let me go back to the data. Oh, Chris Darrow. Okay, Chris, I had 2 different values there. The shift by minus or by 1 seems arbitrary. Instead of 0 inflated, you now have 1 inflated data. No, it's not 1 inflated. Watch what happens. Let me go back. I'll show you what's happening. Okay. Here's the data set, okay? Now watch what I do here. This is what the data looks like. Okay, this
You're not sharing yet.
Oh, I'm not sharing. Oh, sorry. Let me go back to this. Okay, here's our wine data. Right there. Okay, here's our wine data set. Okay, now, I like it to be lowercase. Proc print data equals in file observations equals 10 run. Okay, here's our data set right there. Okay, so here's our data. Now, let me just do a proc variant of this guy. And there it is. Okay? So, I just thought of something here. One minute. I have to go back to my hurdle model. Just 1 minute. Because now I think I might have made a mistake in my example. There's my winter sync session. Just a second. I apologize for the delay here. That's the beauty of office hours. No one expects anything from you. Okay. Logistic. You know what? I just realized something. I shouldn't have done this like this. Okay. You're right. The way I did this in the example was incorrect. Okay. So here's what we're going to do. The first thing that you do is let me create this target flag here. So let me first, okay, so here's our data. And I realize I made a slight mistake before. Okay, so here's our data. Now here's what we're going to do. The first thing we do is what the heck, I've got it right here. I have the target flag is going to be, if the target's greater than 0, it's going to be 1. Otherwise, it's going to be 0. And then I'm going to subtract 1 from the target amount. So let's do that real quick. I'm also fixing some missing values. Okay? So there we go. Now, if I run the proc univariate now, this is what we're going to get. I made a mistake. This should be in file here. It doesn't matter yet. Okay. So down here we have temp file, and let's just do two things. Target flag, was that the guy right there? Target flag. Okay, so now we're going to have this guy to model. And you see that we've got a big spike at most people do buy the wine, but we have a guy over here that says no wine is being purchased. Okay. So now the second thing is, let's do the second one. Now the second one is the amount. Remember we subtracted 1 from it? So what we would do here is if you do a hurdle model, this is what you would do. You would do proc logistic. Let me get this guy. Let's bring the logistic regression. Here it is. We would do something like this. And we would do a proc logistic regression to predict whether or not the guy is going to buy wine or not. So we're just going to do that. Now I know your question. I promise you we're going to get to it. I might have in the last quarter made a mistake, which is why you're confused right now. Okay. So you do this, and we now have these variables here, and you can predict the probability whether or not the guy's going to buy wine. Now, let's take a look at the second thing. We've got this target amount here, right? And if you remember, we subtracted 1 from it. So if I run this, then we now have a value that shouldn't be there. That should be, why is that guy that way? Target amount. What did I do up here? Oh, okay. That's what I did. I didn't make a mistake. If the target amount is, I subtract 1 from it, and then I'm saying if it's negative, I'm going to make it a missing value. That way, what happens is I throw it away. Okay? So that's what I'm doing. I forgot that that's what I did last quarter. So the question is this. So the first thing I'm doing is I'm modeling this guy right here. Then I'm taking the target value and subtracting 1 from it. Now let's get rid of this guy right here. Okay, if you don't have that line, this is what it's going to look like. It's going to look like this. It's going to look like this, and it's going to have a big spike at -1. So it's going to be a -1 inflated model. But we don't want that. So what we're going to do is we've got this line in here that's just simply telling SAS, hey, listen, if this thing is actually a 0, in other words, this was a 0, then we're going to throw it away. So now let's do that. And now the data looks like this. So it used to look like this. Let me get both of them simultaneously. It used to look like this with that big guy there. So now I shifted it. Everybody got shifted one over, and this guy got thrown away. And now I'm just going to model a Poisson model. So this is what the data set looks like now. However, when I'm done modeling it, I have to add one back to my model. Now, I have probably lost absolutely everybody in the class at this point because I did a very bad job of explaining this, and I'm hoping everyone's not crazy, going nuts at this point. So let's take a quick look here at what everybody said. The missing values, when you run ProcGenMod or any of the models, the missing values, because it doesn't have a target, okay, the target is now missing, SAS will throw them away and not use it for building the model. So what about the scoring? So I'll show you how to do the scoring in a minute. So we are basically separating the two data, one from 0 and one. Yes, you're doing. The first thing you're going to do is we're separating the zeros and the non-zeros, and then you're taking the non-zeros, and then you're trying to figure out how many of those guys there are. I really have done a very bad job of explaining this, and I'm hoping you guys really do get this. So, Johnson Tan is typing. Let's see. Okay, it says, speak now or forever hold your peace, as they say. I think I got it, though it seems like a funky way around town. Yes, it is. We're playing a few games here. If you didn't subtract 1 from this guy, let's just see what would happen. So let's just do it like this instead. It would look like this.
Not sharing.
I'm not sharing. Oops.
Nope.
Sorry. That was what my teachers used to say when I was in kindergarten. Plays well with others. Check minus. Okay. So if, yeah, and running with scissors, yes. So if I don't subtract 1, the data set looks like this. 1 is my lowest guy, and just goes on up. Now, if you want to know the truth, and the reason why we subtract 1 is because a Poisson distribution has a 0 value, and we've just thrown them all away. Okay, so if we shift it down, we now have officially a Poisson distribution. Now, again, don't lose any sleep over this if you forget to do this. If if you just built a model like this, I would bet dollars to donuts that your model is going to be almost exact accuracy as if you did subtract it. Now, what do you do when you want to deploy this model? Well, take a look at what I did last quarter. Okay, here's what I did. I built a logistic model right here. Okay, and then I built a GenMod, which was I used a negative binomial, but it could have just as easily been a Poisson. And I built another guy here. Now, when I wanted to deploy this, how did I do it? Well, I came down here, and I've got this logistic model so if you ran the code, this here would give you the probability that the person did buy wine. And then here is if he does buy wine, how much does he buy? Okay? However, remember that we subtracted 1. So we got to add that 1 right back, right here. So you add 1 back to him, and then you multiply him by the probability. So this is going to be a probability severity model, but if you subtract 1, you got to give it back. Is this making sense to everybody? ZNIB is not available. Oh, it isn't? 0 ZNIB. I don't think it's ZNIB, is it? What is the... I'm just going to see what the model was. I think I have it down here somewhere. ZINB. So it should be ZINB. Is that the model? Is that the... wait a minute. ZINB is distribution if you want to do negative, a zero inflated negative binomial. It's ZINB. So is somebody saying that we don't have that available? Is that what I was reading?
That is what's typed. So, saying in SAS Studio.
Oh, wow. Okay. If you don't...
Although,
go ahead.
Let's take RJ. RJ, let us know how it comes out. RJ is running it right now in SAS Studio.
Okay, let's find out. And I have a menu available of distributions. Is not available. Okay. It's possible. I think ZINB was a recent addition, so it's possible I have it and you guys don't. Fine. If you don't have it, no problem. Just use zip. And if you want to know the truth, I think I got the exact same answers with zip and zero inflated negative binomial. So just use zip instead, and you should get the same. You should get a, this one should work. Let me find out if that. Well, that RJ, could you make sure that zip works for you guys? Is he saying it's working or not?
Hasn't done zip yet. He's doing it right now.
Okay. Works for me, but those damn Hessians are still in the gate. Okay, Richard was getting some message about Hessian matrices and all that stuff. When you run logistic regression and GenMod and a few of these other things, you occasionally will get some warning message that says that it doesn't converge or it didn't meet some criteria or whatever, blah, blah, blah. Basically, that's SAS's way of writing an annoying message to you that says, hey, this may not have converged to the best possible answer, but it's a pretty good one, is what that basically means. The real truth of the matter is this. If you get that message, what are you going to do? You're going to just, throw away all your results and say, I'm sorry, boss, I can't solve the problem. No, you're going to give them what you got. You're going to say, here, this isn't a perfect model because SAS isn't able to converge to the best thing it could. However, look, it's still better than doing nothing, and we're making money, and it makes sense. So basically, in the real world, I get those messages all the time. Everybody does. And for the most part, what happens in the real world is people go, Hessians. And then they say what Richard Meyer says is, weren't those the guys that fought Napoleon or somebody, or in the Civil War or something? I know that there's somebody named Hessians that fought in a war somewhere.
Yeah, we hired them for the Revolutionary War against the Brits.
We did?
We did.
Okay. So German mercenaries for the British. So they're bad guys or good guys?
I thought we hired them. My mistake. I wasn't around then.
Other way around. We hired them away from the British. Okay, they may be good or they may be bad, but if you get a warning message, they're annoying. But most people sort of shrug their shoulders and don't know what to do with it, and then they go on and they pretend they don't see the warning message. And in fact, Richard, you're the first person that's asked about this ever, so that tells you how concerned people are about this. They're in it for the money. Hessians, one capitalized, a native of Hesse, a German mercenary serving in the British forces during American Revolution, a mercenary soldier. Bingo bonus. I don't know if I give bingo bonus for history questions, but I'll think about it. Okay, so anyways, let me just, for fun, let's finish this guy up. Here's the. Let me go back to this. Okay, so I have.
We need to share the screen again.
Oh, sorry about that. Share. So, anyways, let me get rid of some of this data here that I messed up my nice little example for you. So I'm going to get rid of this guy here and make this guy back the way he was, although I'm not using that right now anyway. So I wanted to show you guys, if you had a zero inflated Poisson, a zip model. So I showed you last quarter how to do it if you wanted to do a hurdle model. So it's called a hurdle when you do a logistic model and then you subtract one and then you build yourself a Poisson. That's called a hurdle. It has to jump over the hurdle, and then it's like a probability and severity. That one I've shown you last quarter, so just watch the video last quarter, and I've got an example of how to do it in the code from last quarter. What I want to do here is make this very pristine and only have the data to show you guys how to do it with a zip model, okay? Because I didn't do that last quarter. So let me get rid of that. Let me go up to the top. Let me just rerun all this stuff here. Okay, there we go. Now let's run this guy. Now the first thing I'm going to do is just copy this guy into a new data set so that if you watch the video last quarter, you'll know why I did that. Okay, here we go. Here's the GenMod. And I've got this target variable, which is going to be the raw value. In other words, I'm not going to create that flag, and I'm not going to subtract one from it or anything. I'm just going to use GenMod exactly with the raw data, and I'm going to make this a zip model. Okay? So what I do is I type model, here's my target, and I'm going to use these variables. What would be kind of neat is if you decide to use, let's say, linear regression, you might use the linear regression and then choose the variables that linear regression liked and use those in your GenMod. I mean, you can use some creativity in this. But anyways, that's this guy here. Now, the second thing you got is if you have a zip model, you got to have a zero model. And this is going to be the probability that 0 things happen or people buy 0 wine. Okay? And then I'm going to do this output statement, and I'm going to, this is going to be the prediction of how much wine the person buys, and this is the prediction of what's the probability that he doesn't buy any wine at all. So if you run this, you're going to get this guy right here. And you're going to see you get 2 sets of parameters. The first guy here is, this is the parameters for, the first guy here is if the guy does buy, better make sure I'm doing this right. Okay, so the first guy here is if he does buy wine, how many cases does he going to have? How many cases of wine? So I've got these guys here. So what I'm going to do is I come down and I just put those guys right here. Okay, that's the formula right there. This guy, these parameters, I put those right here in the formula that I got. Okay. Now the other thing that I did is up here, SAS also gives me the probability that he's not going to buy any wine at all. So this is the probability that he's not going to buy wine. This is the probability of a 0 right here. And this is just a logistic model. So if you look, I've got that code right here. Okay, now I've got this code in here because it's probably a good practice to not let your values, because you got this guy, and this is the log likelihood, and if everybody remembers from last unit, this is the log likelihood, but you got to convert it to a probability. How do you do that? You do exponent divided by 1 plus the exponent. Unfortunately, if that number gets really big or really small, you start getting all sorts of trouble because you get rounding errors. So what I do is I just say, hey, listen, if it's greater than 1,000, cap it off at 1,000, and if it's less than minus 1,000, cap it off. You know, I'm just capping it so that the probabilities, you know, that the math is correct, but the computer can't handle really big exponents. So that's what I'm just doing here. So I have now the probability that the guy doesn't buy any wine, but we don't want that. We want the probability that he is going to buy wine. So we do 1 minus that value.
And while you're on this, Thomas McDermott says the likelihood estimate may be missing a parameter.
It might be. Which one? I have stars, label, and M. So let's see. I've got stars, label, and M. So I've got 3 parameters. And if you look at it, let me look at my code. My code only had 3. 0 model, I used stars, I used the label appeal, and then I used was anything missing. So I only had 3 parameters. Thomas, are you sure that is that what you were asking? Is Thomas McDermott typing anything?
He is typing now. Density.
Yes, but density this is for if you did buy wine. So there's 2 models here. This is the 0 model. I didn't put it in there. I deliberately didn't use the same variables because I'm trying to show the students that it doesn't have to have the same parameters. Does that make sense to you, Thomas?
He says okay. And yeah.
I wonder if is that a real okay, or is that one of, I'm afraid to ask a question. I don't want you guys to hang up without getting it.
He's typing. And then I have another post I'll read you in just a second.
Okay.
No, I get it, though I thought they had to be the same.
Nope, they do not have to be the same.
Okay, then up above, Richard Meyer, would you recommend using the class option for, say, for example, stars or labels, or labels with the zip model, because that's what brings on the Hessians, the class option.
Short answer is technically you probably should use the class option. I was lazy and didn't use it. I'm just using the stars in its raw format. But if you want to be a good purist about it, you probably should do that.
And Richard says thank you.
Okay.
Makes sense.
Okay. Now, people are going to say, well, why, Don, did you put this guy in here? Well, the reason why is this. Okay, incidentally, this is the predictions that I had from last quarter. Okay, remember how I did that whole big 2-hour session last quarter? These are the models that I got last quarter. I kept them in here so that we could do some quick comparison. Okay? So this is, if you just use plain ordinary vanilla regression, here's a GenMod with a negative binomial distribution. Here's a hurdle model right here. And this is the one we're doing right now. Okay, so I'm going to put this right here. This is what we just did. Now, what I did was, for fun, I wanted to show you something, which is, in theory, this guy right here should give you the same answer, because it's got the same parameters and everything, should give you the same answer as this guy. Unfortunately, probably has something to do with those darn Hessians. I don't know. It's close, but it's not perfect, and it's a noticeable difference, like 1 or 2%. And I didn't go into SAS technical support and ask these guys why that's the case. If you want my professional opinion, I would be willing to bet that the algorithm that the guy who wrote this thing up is slightly different than the algorithm that this guy used. Because when you start getting into this maximum likelihood kind of stuff, you now are moving away from, linear regression is linear regression is linear regression. You and I get the exact same data, and we do the exact same operations. We're going to get the exact same output. When you start getting into things that involve trial and error, you start, one guy may take some liberties that another guy didn't take, or make assumptions or whatever. You could start getting slightly different answers, and that's what we're getting here. So I just wanted to show that right here. So let me just run all this code, because this is starting to get messy here. I want to make sure I didn't forget to run anything. So here's my score program is right here. So this is the regression from last quarter. This is the negative binomial from last quarter. Here's my hurdle model from last quarter. And here is my zip probability. And here's my zero inflated Poisson. I have ZINB, but it should be zip. And then for fun, I did an ensemble. I just averaged those 4 guys together. Because you know what? Sometimes that gives you a good answer. And then I rounded everybody to 1. Okay? Now, just for fun, let me show you these probabilities here. And to test my answers, this is the guy that came out of Proc GenMod, and this is my score program. You can see the answers are very close or the same. So if I look at that, P0 probability is right here. And this is when I got in my score program. X0 probability is what came out of GenMod. Okay? I said, hey, give me this give me the probability. This is how you're supposed to test your programs, okay? Some of you guys didn't test your programs and you had typos and what have you. This is how you do it. You make sure that your test data that you built your model is giving you the same answer as when you run it through the score code. Okay, so I ran that guy, and you can see that GenMod and my score code gave me the same answer. Okay, now let's take a look at the logistic model. And, well, yeah, actually, this is giving me the probability that it's 0, and this is giving me the probability of 1. So let me just do something really crazy real quick. Michael, am I losing everybody? Are their eyes glazing over, do you think, or are you following what I'm doing?
I'll be honest, it's a little bit over my head, which is not saying much.
Well, you know what? That means I'm doing a bad job here. Okay, I'm not gonna walk down this path. Okay, punchline is I am testing my score program versus what GenMod did to see if they came out with the same answer. Okay, I'm not going to go any further than that because I think I'm about to confuse everybody. Okay. Michael, tell me this. Do you follow what I did right here with this score program? And be honest.
I do. I'm going to have to look at your code after class and run it myself in order to fully understand it. I get the concepts, though.
Okay. This is the output or the answer I got from last quarter. Remember I had that sync session from last quarter and I built a bunch of models?
Yes.
Okay. This is from last quarter. I just wanted to keep it around and bring it into this thing so we can test to see how accurate the model is compared to running a 0 inflated Poisson. Are you okay with that?
Makes sense to me, yes.
Okay. This is the negative binomial I ran last quarter. I'm bringing it in now to see how it stacks up. This is the hurdle model I ran last quarter to see how it stacks up. And this is the guy I just ran right now. This is the P0 probability that I got from running this code right here. And this guy right here got put right in here. And then I have to multiply this guy by 1 minus this guy. So that's what I'm doing right here. Okay? I'm rounding everybody to the nearest bottle of wine right there. So are you okay with that so far, or do I need to go through it?
I was good until you got to the point where you multiplied one. I don't see it on the screen anymore. 1 times the other.
Okay.
Oh! I'm sorry. You were multiplying the likelihood of 0 or 1 times the actual number
right.
of bottle spots. Yep.
Yep. That's what I'm doing there.
Got it.
And the reason why I have 1 minus is because proc GenMod gives me the probability of 0, so I want the probability of 1. So what's the probability that you're going to buy a bottle of wine, and then there's a 10% chance you're going to buy 100 bottles. 10% of 100 means your expected is 10, because 10% of 100 is 10. So anyways, let me run these guys, and let's just jump right to the... there's days that I do this, and I'm like, man, I'm firing on all cylinders. I know everybody got it. I'm really proud of myself. And then there's days that I feel great shame. Today is a day that I feel great shame because I think I've confused everybody. Okay, but let's go with this anyway. So let's just print the various, what happens here. Okay, so this is, the guy bought 3 bottles. If I used linear regression, it predicted 4. Negative binomial predicted 4. The hurdle model predicted 4. 0 inflated negative binomial and ensemble, which was an average. So you can see this is kind of what happened is you can just eyeball these things. And if we just eyeball them, you're going to see that, you know what? They all kind of did a pretty decent job of predicting what really happened. But just for fun, let's go down here and let's calculate the error. So this is the error that the regression had. So here's what really happened. Here's what my model predicted. And I'm going to take the absolute value of that. And then here's my negative binomial. This is what really happened. This is what I predicted. This is the hurdle model. And so these are the errors. And then I'm going to just calculate the average to see which one was the best.
This makes great sense, and Benjamin Burns says you can still recover.
Okay. So what I'm simply doing here is you can see that I've got the error, the regression of the error is on the average, I've got about 1.02 bottles. So I'm usually off by about, if I just use plain Jane vanilla regression, and it wasn't even a good model. I wasn't even trying to get a good model. I was just throwing data in there. Okay. So, but just throwing stuff in there, I end up being off by 1 bottle of wine. If I'm using GenMod with all the complexities, look, I'm off by a little less than 1 bottle of wine. If you look at the difference between these two guys, it's 0.04, 4% difference. If you want to know my personal opinion, I would go with the regression over the GenMod every day of the week, because the regression, I can explain that to my boss. And this one is very hard because I've got all sorts of exponents in there. And this hurdle model is even more complicated. Okay, fair enough. There's probably about an 8% difference. But you know what? I probably still might go with this guy right here, because we know linear regression is so easy to explain. And it's so easy to implement the models. I don't know. I'm just saying my personal preference would be I'd go with this guy. Now, if we ended up doing something with, where the mistake, if you have an error, it's going to be very, very, very costly, and accuracy is critically important, then, maybe we might choose one of these other models. But I can't believe a case of wine is going to be that big a deal. So I would probably just, my instincts tend to suggest go with this first guy.
And Johnson points out, though, that you may have to use the additional methods if you want bingo bonus from beating the professor's model.
Yes, but you don't even know the metrics that I'm using.
Oh.
You don't know. This is the metric I'm going to... Well, first of all, let me tell you this. This is testing on the training data. Are you following me? In other words, I'm just running this on the training data, and they all look about the same. It's very possible that on test data, this guy right here might just win.
Good point.
Aha. I'm going to make you guys analytic street crawlers if it's the last thing I do. So let me stop sharing, and let's go back here. Now, but OLS can give varying results with different samples as it's violating the residual. Yes, you're right. Rana J is saying that OLS, we are violating about 1,000,006 different assumptions of OLS regression. However, Rana J, if you remember from back in 410, they had you read that paper about John Tukey. And incidentally, John Tukey is a very good name to know if you take the final exam. So it's violating a bunch of rules, but John Tukey was saying, look, even though you violate a bunch of rules of linear regression, you still end up with a pretty good model. Does the assignment, I said I can't recommend the regression model? I really say that? I don't remember that. If I did, I shouldn't have done that.
Can we ignore that?
Well, let's see. How will I know it will do this? It will do the sample in other samples. You would have a holdout. In a real world, Rana J, is what you would probably do is you would take your training data and you would break out a sample and you would say, okay, here, I'll show you how I would do it. You really want me to show you how to do it? Let's go old school here. Okay. You want me to show you how to do it? We're going to find out how well it does. Okay, here we go, gang. We're going to go old school here. We're going to go medieval. Okay, way down here, I'm going to create a variable, and it's going to be called test flag equals ran uni 1. Whoops, less than 0.2. So 20% of this data is going to get held out for test.
Pardon my ignorance. What's ran-uni?
This is going to create a uniform randomly distributed number, and 1 is the seed.
Thank you.
Okay, so let's run this guy again. Now, just for fun, what we're going to do is, this is actually bad what I'm about to do because I'm still testing on the training data, but how about if we just do this anyway? If test flag equals 0, then delete. There. How about that? So I'm only going to keep a small subset of the data. This is actually very bad technique. I should really create a holdout sample and not ever use it to build my models. But if I do that right now, I'm going to have to re-alter all my code. I don't want to do that, okay? So I'm just going to have a little holdout sample. So let's do it now and see what we get. Okay, he still gives me this as an answer, 1.02, 98, 97, 97. Okay, let's change it to something else. Let's change this random number flag to 2. So in other words, I'm going to do a different random number. I'm going to put the data back in the bag and see what else we get and pull out new data. Let's see what we get. Okay, so now we got 3%, 1%. The ensemble wins this time. Well, no, the zero inflated Poisson wins. Let's do it again. Let's change this to 3. Michael, do you see what I'm doing here?
You're generating random numbers for the test flag and then running your same model against that random set, and you're only using 20%, and you deleted where values equal 0.
So I'm only going to use 20% to test. In other words, I'm just randomly pulling a set of data out to test on it. This is a bad way of running a test, but it's still not bad. I mean, it's not. There's better ways to do this that I'm doing, but this is a quick and dirty way of doing this without having to re-alter out my code. So, you know, in this particular case with this data set, the regression is consistently underperforming some of the other ones, but it depends. Sometimes the ensemble wins, sometimes this wins, sometimes. So it's kind of hard to know which of these guys is going to win. But the point is they're all kind of the same. Now, the point is, though, this regression is consistently doing a pretty darn good job. Even though we're violating the assumptions, my point is I want you to say, look, this is still a viable, John Tukey, it was heresy. He was running around saying, look, we can violate the rules of linear regression and still end up with a pretty good model. So just sort of keep that in your bag of tricks. Are we hiring the Hessians? Okay, thanks. And Rana J., you don't have to agree with me. I'm giving you my opinions, and there's a lot of pure statisticians out there that think what I'm saying is totally crazy. So you do not have to believe what I'm saying. I'm just simply giving you, there's a school of thought that says you can go ahead and violate the OLS assumptions and still end up with a pretty good model. Is exactly it. You don't have to, and you don't ever have to believe this at all. So one of the things I want you to remember is I'm giving you opinions based upon my experience and what I've observed on other people, but I can be wrong. So if you don't agree with this, you don't have to follow it. Do larger data sets make proc reg less error prone? I think that is my personal opinion. The bigger your data set, the more robust linear regression becomes. So there you go. You guys want me to, let's see, it seems like a classic divide accurate predictions interpretable. Yeah, it is. That's what I go with, RJ, is I personally, I like my model to do three things. I like to have accuracy. It has to make sense. I mean, interpretability and making sense. Like, for example, let's say I build a predictive model, and it's insanely accurate. And I'm trying to predict who's going to crash their car. But for some reason, my model keeps saying people who like to drive drunk with a blindfold on and, going 80 miles an hour in a school zone the wrong way, and they never crash their car. Okay? That makes absolutely no sense. I don't care if the model is perfect. That makes no sense. And just common sense tells you that's wrong. I would never tell you to put that model into production, even if it's perfectly accurate. There's something wrong. Okay? So your model should always make sense. Now, there's trade-offs a little bit. You can have some things that are not quite accurate, little errors here and there. But the crazier that model is, the less likely I'm going to use it. He had the same response as me, or he had the same response that both. Well, my school was a waste. No, RJ, it's not a waste. You have to understand the theory before you break the rules. This is what the other guy, predictions are God. No, they're not. If the predictions come from a model that makes no sense, I don't have any stock in it. And hell, if nothing else, just from a practical standpoint, if you walk over to your boss and say, hey, we should only give insurance to drunk drivers, you're going to get fired. Okay? So just remember that. I mean, if nothing else, be practical about this. If it doesn't make sense, if your boss is going to fire you for showing him the model, better rethink the model, okay? So I'll tell you what I'm going to do. It's 10 o'clock. What I think I'm going to do is I might do this machine learning talk later in the quarter, like after, the final week of the quarter.
That would be nice, so we can really devote a lot of attention to this lesson and then fully absorb your machine learning talk.
Would that be okay, guys? I don't want to short shrift you, but I don't want to, throw too much in at you. So I'll do whatever you guys want. You're sleeping. You're feeling sleepy now. Okay, so I'm gonna do a zero. No, this isn't zero inflated. I'll do a machine learning talk later in the quarter. How about that? Okay. Now I've totally confused everybody, but do you understand? Does anybody have any questions, comments? Now the real question is, am I going to like this or not?
Can we see the label?
The label's upstairs. I don't even remember what it was called. I just poured this as a visual aid. Okay, I gotta drink this here. Let's see. It's wine. It's good. So this was. You guys should all, in your final or your reports, everybody should take a screenshot of themselves drinking wine and putting it in their write-up as a visual aid. If you don't drink, that's fine. I'm just doing that as a joke. Don't. There's probably somebody out there who's got a reason for not wanting to drink, and I don't want to be the guy saying drink. If I wanted to learn how to drink from the Twitter fire hose, what would be the You know what? I don't know a thing about Twitter. So, Richard, I can't give you any good drinking on the job. Yes, I guess technically I'm drinking on the job. Bingo bonus if we take a picture of the best seller. What's the best seller? It's either if we take a picture of the best seller, it's either the text mining or the web analytics, right? Yeah, but I don't know what's in either one of those classes, Richard. I'm sorry. No, you don't get bingo bonus points for sending me wine. You don't. Whatever wins our model predicts will sell the most. Well, I don't know. The wine is just all generic wine. I don't even know if does it tell you? Was this good wine? Yeah, I guess this is pretty good wine. I think this wine is called, I cannot remember. $2 Chuck. I don't think so.
Their label sucks.
My sisters drink $2 Chuck. But it's $3 Chuck now, I think. Is it from a box or a bottle? It's from a bottle. So there you go. Guys, I got nothing else. Does everybody have their questions answered? I'll post this video in a little while and also the code that I used. If I've confused you, I most sincerely apologize. I didn't mean to do that. I hope I at least cleared up some of the problems.
Yeah, once we look through the code, I think that will help. That will help a lot. That'll help reinforce the messages.
Okay. Okay, I'll post the code later on. But you should, if nothing else, watch the code from last quarter. I think I did a better job explaining it last quarter. Am I going to tell you what I did to mess with the data? I don't know if I messed with the data. I think this data came as is.
I have a big picture question. When you say that you can use decision trees and such, I did that in my first assignment. I pulled all the data out into Weka and let it do to impute the missing values, and then pulled it all back in using Angus and all kinds of conniptions. Is that what you had in mind?
If you could do that in an automated fashion on all your variables, it would be great. I would not do that for every variable if you're going to do it by hand. One or two variables to say you know how to do it. Maybe a variable that you think is important, do it to one of them. That's what I had in mind, just to get a flavor for using a tree for that purpose. But if you did it for every one of those variables, that would take you forever.
And since it's Studio, we can't do decision trees in Studio. We have to use Weka or Angus or some similar.
Right. Some students found some SAS macro out there on the internet, but I wouldn't do that. I would just try to use Weka or Angus or something like that. Just my hope is that I just want you guys to start getting into the habit of using decision trees. They're such a powerful tool, and you will have a competitive advantage over everybody else because they're so powerful and they're so underutilized. You can use them for variable selection. You can build models with them. You can do missing value imputation, look for multivariable interactions. There's a lot you can do with those things. Can you output SAS to a CSV file? Yes, you can. Ott said you messed with it to mess with us. I probably did. I messed with some of the data. I'm not sure if I messed with the line data. You messed with Ott. Professor Ott knows more about me than I know about me. I sometimes worry that he's cyber stalking me. I think what I might have done to mess with the data was occasionally deleted some of it. Because some of the data that I get is pristine, and so I don't want you guys to get. So what I think is I go and randomly delete some of the data. So that's probably the way I messed with the data. You didn't reverse signs? I don't believe I did. But I would have to go and look up my old code somewhere. But Benjamin, just because I'm saying no doesn't mean that's true. It's I don't think I did. So I could be wrong. Remember, Don could be wrong. Remember, I did this stuff. I was pulling these data sets together in a frenzy like 8 months ago. So I don't know. But the data is definitely fighting back, isn't it?
Mm-hmm.
So I'm going to stop the recording at this point. Well, unless anybody has any more questions, I'm going to stop recording because I don't want to. So stop recording.